So now that we know how to differentiate, we need to look at what happens when we have a slightly more complicated function. So in our previous examples, we were always given functions where we had our powers on our x's, but we can apply our laws of indices from National 5 to be able to help us to manipulate functions into forms that are suitable for differentiation. So for this first example, we've got g of x equals 2 cubed root x plus 1. So that cubed root of x isn't what we're used to, so we're going to have to manipulate that a little bit. Now notice that our function this time is g of x, okay, so you can treat that the same as f of x, but obviously just write it as g of x. So if we've got 2 and then the cubed root of x, what we have, thinking back to our laws of indices from last year, is 2x to the power a third. So remember that 3 is your root, and there is a 1 there that we don't always write, so your root comes over and becomes the bottom of your fraction. That's where I'm getting that third from. And then that plus 1 is absolutely fine as it is. So this form here is differentiable. That form needs manipulated. Okay, so this is what we're going from. So please be very, very careful. Make sure that you are writing this one as g of x, because these two things, what we were given in the question and what I've just written, are the exact same thing. Do not jump a step and write that that's g dashed x. Okay, so they are both my original functions, just written in different ways. So for my derivative, I'm going to take the fraction, I'm going to move my fraction down and multiply it. So 2 times by a third gives me 2/3. My x stays exactly where it is. If I decrease a third by 1, I get a power of negative 2/3. If you have to do extra working for that, then feel free. You will get more confident with it as you practice it. So if we've got a third and we're decreasing it by 1, remember we need common denominators. So what we're actually doing is a third take away 3/3. 1 take away 3 gives me negative 2/3, and that's where I'm getting that negative 2/3 from. Think back to the last lesson. If we have a number on its own, that number just disappears. So this here is our final answer. So we would get marks for that. However, there are occasions where it is in your best interest to rewrite it as fully simplified as you can. So in other words, getting rid of that negative power. So I'm going to start to manipulate it through just to get it as simplified as I can. So that is the same as 2/3x to the power 2/3. So my 2 and my 3 from my fractions are staying exactly as they are, but I'm bringing this x down to make it a positive power. Remember, we can also rewrite that fraction. So that's going to be 2/2 cubed root of x squared. So the 2 stays where it is, and our 3 moves round to give us that cubed root back. That would be my final answer simplified. So either one of these would get you the marks, but as I've said in the previous lesson, there are occasions where it's in your best interest to simplify it as far as you can, but I'll point them out as we're going through it. So looking at our second example, you can only differentiate if everything is on your top line. So this x squared on the bottom is causing us a little bit of a problem here, but that's an easy fix. So our function, I'm going to rewrite it as y equals 3x squared plus laws of indices from last year. That x can move up and become a negative 2 on its power. From there, it's set up nicely for me to differentiate. So remember, if you differentiate y, you get dy by dx. I'm going to bring this 2 down and multiply it by the 3 to give me 6x. Decrease your power from 2 goes down to 1. We don't have to write that one. Move on to the next part. Negative 2 comes down and multiplies. So this time we've got a positive, but we're timesing it by a negative, which is going to give us a negative 2. X stays where it is, and we decrease that negative 3. That negative 2 goes down to negative 3. So this would be perfectly acceptable as your final answer, but then as I've been saying, there are occasions where it would make sense to simplify it a little bit further, and we could write that with our minus 2/x cubed to give us our positive powers instead.